Now that you know how to measure courses, compute headings, gauge ground speeds, tally times, and figure fuel required, you no doubt realize that you're going to compile more than a dollop of data. And you probably need a place to put it all. Can you see where this one's headed, gang? You got it. Paperwork. Only in this case, it's paperwork that actually helps and is actually kind of fun to put together. Through the years, pilots have devised a reasonably organized format to keep track of all that information and make the best use of it. Several commercial companies have printed their own versions of flight or nav logs, any one of which will work. The differences are personal preference, and your instructor or flight school may prefer one over others. So, the flight log we're going to use may look a little different from yours, but the concepts are all the same. First, let's check out the overall organization of this log. Each line will represent a leg of your flight in between checkpoints that you've selected along your route. The checkpoints are all listed in this far left column right over here. And the left side of this navigation log is filled in during your pre-flight planning, and it's where you'll do the calculations to determine the heading for each leg. And the right side has some pre-flight data such as distances, ground speeds, and ETEs, or estimated times en route. It's also the area you'll use for your in-flight notations. Now, let's start filling in this log just as you would when you're planning across country. Now, let's say we're going to fly from Richfield Airport to Mount Pleasant Airport to the north. Here it is right here. We've already filled in the first leg for the climb out, and that's this leg right here. It shows us climbing out. And now let's fill in the line for the second leg, which proceeds from the level off point all the way to Salina Gunnison Airport. And we'll fill in this leg right here. We can enter our true course, which is right here, or 036 degrees, and our altitude we've selected is 9,500 feet. Next, the wind direction and speed the weather briefer gave us for this altitude were 350 degrees and 20 knots. And that will stay the same for this flight and these legs, so we'll just continue with the line. Next is the temperature, plus 5 degrees Celsius. We'll put that in this box, of course, again, temperature. Now, this is the outside air temperature, and you'll also need to get that from the weather briefer, but you will have to ask for it. Next, we need the planned true airspeed, which you can find in your Skyhawk's information manual. And here's TAS for true airspeed. In this case, we'll use 110 knots for this example, and it goes over here in this part of the navigation log. We'll talk about the calibrated airspeed block in the cross-country lesson, and that's right up here. Now we have all the pieces to figure out the wind correction angle, or WCA. Notice that it shows right here that the WCA is negative if the wind comes from the left and positive if the wind comes from the right. In our example, we figured it to be to the left 8 degrees, so we will enter -8 right in this block for the WCA. Next is true heading, and notice here that the line is divided into 2 blocks again, true heading and the variation. The top is for true heading, the bottom for variation. So we'll get the true heading. We take the true course, which we said earlier was 036 degrees, then add or subtract the wind correction angle from this block right here. Well, since we already stated that our WCA is -8 degrees, we'll subtract it from the true course of 036 degrees and get 028 degrees and put it right into this box here. In the bottom block, we'll enter the variation from the chart for our route of flight. Alrighty, this is our destination airport, and as you can see, the variation in this area is 13 degrees and 30 minutes east. But since we can't really fly a half a degree, we'll use 14 degrees east, especially since our route is actually closer to 14 than it is to 13. Now this is a great form for those of us getting a little long in the tooth, because right here it reminds us to subtract for east and add for west. So we put our minus 14 in here because remember, east is least and west is best. So next is the magnetic heading, which is another split block. Here's our magnetic heading right here. The magnetic heading is on the top and the deviation is on the bottom. Now, to find the magnetic heading, you take the true heading, 028, and subtract the variation, in this case, 14 degrees east, which, if you made it through grade school, will leave you with 0, 1, 4, and we put it right into that box. Now, down to the bottom here, you'd enter the actual deviation for the heading you'll be flying. We'll wait to put this in and figure out the compass heading when we get to the airplane and check the deviation card. That completes the columns on the left side, but there are some things over on the right that we can do now also. First is the distance, which we measure from where we think we'll be leveling off to the next checkpoint. In this case, we believe we'll be leveling off 15 miles after takeoff, and we can put that in right there. Now, we figure this out from the time, fuel, and distance to climb chart in the Pilot's Information Manual, or PIM, which, silly me, I thought always meant pinheads in management. And you wonder why I can't keep a job. Now, if we calculate 15 miles, it puts us right here. This is our starting airport, Richfield, 15 miles, and by golly, there's a terrific reference point right here. See this road that goes west out of Salina, or maybe they call it Salina, I'm not even sure, but we know where we're going now. This road heading west, just beyond our level off point, tells us if we arrive there early or late based on when we cross this road. So for planning purposes, we'll plot our level off right here, 15 miles. The distance to the next checkpoint, Salina Gunnison Airport, is 6 nautical miles, so we put 6 in the top block for this leg, and this is the distance in nautical miles. We'll put 6 in here. And the bottom block represents how many miles remain until your destination. We'll figure that out when we've completed the pre-flight planning. Now the next block is for our estimated ground speed. You see GS right here, which we derived from the wind side of the flight computer, and it turned out to be 95 knots. So let's put 95 in there, please. Very nicely done. Next is estimated time en route, how long you think it will take, and that's our ETE. And we use the circular slide rule side of the flight computer to figure that out, and it should take us about 4 minutes, we figure. Now below that is the actual time en route, which you will determine when you actually fly that route. The top of the next block is for our estimated time of arrival, and the bottom is our actual time of arrival. Next is fuel used, or how much fuel you will burn on this leg. Again, we use the circular slide rule side of the flight computer and figure it to be 1/2 gallon. And here's our fuel consumption right there, GPH for that leg, which is the top. Good job. So we put 0.5 right there, and below that, fuel remaining, or how much fuel you're supposed to have left in your tanks after you fly this leg. And we will figure that out when we've completed the pre-flight planning. Now you will want to fill a line out for each leg, and we've done it for you by completing the log for this trip right here. Now hold on for just a little while longer because we're almost done. If you look at the bottom here, you will see the totals row. First, start with the distance. This is your distance column right here. We've added them all up and come up with a total of 55 nautical miles, and we place that in our totals right here. Now you can and should check that by filling in the remaining blocks here. When you arrive at your destination, you should have, of course, 0 miles remaining, or else you wouldn't be there, would you? So you enter a 0 here and start adding up in this direction. So if you have 14 plus 20, that equals 34, and 34 plus 6 gives you 40, and 40 plus 15 equals 55. So now we're sure that we've added correctly because our totals agree. Next is the ETE column, or estimated time en route, where you want to know how long the entire flight will take. Add up the times in each row and you'll get a total ETE of 39 minutes. And finally, calculate the fuel burn. If you add up all these, and we haven't overtaxed your math skills, you'll get a total of 6.6 gallons right here. And lastly, start at the top and fill in the remaining fuel blocks. If you started out with 30 gallons in our example, you'd have 23.4 gallons left after flying this complete route. And now that you know how to fill out a navigational log, you, like me, won't have to plague your poor overcrowded cranium with all that numeric minutia.